Okay, so we're going to start here with 3.3 notes. So the first part of this notes are about shapes of graphs, and they're just some different vocabulary that you need to know here. First of all, a turning point. So basically a turning point is anywhere where your graph's slope is going to change. So it's an ordered pair, it's the point, where the slope changes from positive to negative or negative to positive, right? So it's switching. So if I look at that first graph on the left, we see that it's positive, positive, positive slope all the way here, and then this point, you notice it turns, and it becomes a negative slope. So it's literally what you think where it turns. So the actual point would be this turning point right here, so it would be the coordinates 1, 3. So it is actually an ordered pair or a turning point. For this, sorry, there it is, turning point. For this next graph, it's, slope is negative, 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 negative this whole time. And then right here it switches, and the slope's now becoming positive. So it's where we're turning that graph. And so that turning point where the graph switches would be at 0, 0 for this one. Okay, what's a minimum value? Just what you would think it is. But the key word here is value. And value always, anytime a question asks you about value, it's always referring to the y value or the y coordinate of your lowest point. Similarly, the maximum value, again, that word value is the y coordinate. Anytime we see value, it always means the y coordinate of the highest point. All right, so let's go to the graph and find our maximums and our minimums. So for the first graph at the bottom, the minimum value would be what's the y coordinate, right? Value, again, is always the y coordinate. So which one is the y coordinate? The lowest y coordinate here would be -1. And the highest y coordinate that we have would be 3. That's basically going to give you a range, right, from -1 to 3. So your minimum value is the lower end of your range. The maximum value is the higher end of your range. Same thing here. My minimum y value is just 0. My maximum y value is up here at 4. Increasing on an interval. So what that means, interval is your key here, so you need your answer in interval notation. And this is now the x coordinates where your y values are increasing. So I put in the intervals, I actually put the numbers of the x's, but it's where your y graph is increasing. Same thing here for decreasing. Again, it's also going to be interval notation of the x coordinates again, where your y values are decreasing. Okay? So let's look at the graph. So the first graph on the left, where are my y values increasing? Well, notice along this whole line here, my y values are going up. And so I would write this in interval notation, my x values, so -1, 2, 3, 4, 5, to where it turns, which would be at 1. So from -5 to 1. You can do either hard brackets or soft brackets here. Technically, soft brackets are actually a little better because it's not actually increasing at a point at the endpoints, but it's fine to do hard brackets. It doesn't matter. Since they're closed circles, people like to do hard brackets. Then let's look here. It turns the corner and it starts decreasing or going down. So what are these x values? 1 to 4, and so from 1 to 4. And again, the reason why the hard bracket's kind of confusing, well, is it increasing at 1 or decreasing at 1? It's actually not doing anything at 1 because that's a turning point. So that's why you could either use soft brackets or hard brackets or soft parentheses. All right, same thing here. Where is it increasing? Well, it's increasing on the part where it's going up from left to right. So this would be my increasing. So from 0 to 2. And then decreasing is here where it's heading down. So you kind of imagine this having sort of arrows on it. And when those arrows are going down, that's where I would be decreasing. And when the arrows are going up, it'd be increasing. And always read your graphs from left to right. And that's our decreasing interval. Okay, example 1. If I were to graph this on the graphing calculator and find the minimum value, I just want you to remember those steps. And I don't have my calculator right now because I lent it to someone and I haven't gotten it back. So if you have my calculator, please give it back to me. But what you would do if you do notice this and you see this graph, it looks something kind of like this. Okay, the minimum value, remember you go into second trace, which is the calc menu, and then you pick the one that says minimum. And then when you're trying to do minimum, it's going to ask you for a left bound, right bound, right? And then a guess. So I would just go close to this and do a left bound, and then do a right bound, and then do my guess. And then it should give you the coordinates. And again, minimum value, notice the word value, that means I want the y coordinate. And so what is the y coordinate? I believe it's something like negative 5.15. So take a minute, try and graph that on your calculator and make sure you get negative 5.15 for the minimum value. Okay, let's turn the page. Page 9, we're talking about average rate of change here. So that sounds really fancy. But all that average rate of change is, you guys, it's a concept you all know and love, and you have done it for years. Otherwise known as slope. That's all that average rate of change is, okay? It's the slope of the segment, and that's all that this says here. And so all you're doing is remember that delta y, delta x. Remember, delta just means change in. So change in y over change in x. Right? So really, what is this? This is rise over run, otherwise known as y2 minus y1 over x2 minus x1. But now we're just writing it in interval notation, in function notation. So f of b minus f of a over b minus a. Okay, this is a good way to sort of switch from y's and x's to now function notation, f of b minus f of a over b minus a. You're going to see that a lot. So it's going to ask us to find the average rate of change for this function. Our function is f of x equals x squared. So we can just get a nice little graph here. Right, so you've got, right, so here's our nice parabola. And it wants the average rate of change or the slope. Now, this is kind of the first time you're taking the slope of something that's not a line, right? We know how to find the slope of a line. But really, on a curve like this, you're finding the slope the same way. You're doing the change in y over the change in x. So if I go from the interval from negative 2 to 0, that's your a and your b. Okay? So literally, you're going to do f of b minus f of a over b minus a. Well, a is just negative 2, b is 0. F of a, well, f of negative 2 is just 4, and f of 0 is just 0. So then I plug this stuff in. F of b minus f of a over b minus a. And so I get a slope of negative 2. So that's my average rate of change, or my slope, from negative 2 to 0. So let's think about that. That's from negative 2, that's this point right here, to 0, this point right here. So what I just found was the slope of that line. That's what I found. Now, it doesn't go along the curve, but it is the slope of joining those two. Okay? So that's okay. That's how we're finding average rate of change between 2 points that are on a curve. Okay? So just finding the slope between those 2 points. That's all it is. So you can do the same thing for this next one. Again, you can kind of do all this on your own. This is from 0 to 1, so it's just this right here. So what would be my slope? We'll just do rise over run, right? So it would just be 1 over 1. And so my average rate of change, or my slope for that interval, would be 1. And then how about from 1 to 2? Well, again, I'm just going from here to here. So that's up 1, 2, 3 over 1. So it should be, right? And you would just plug this in, change in y over change in x. And we do get 3. Okay, so finding slope on a curve is the same way we don't call it slope anymore, we call it average rate of change. But it's still y2 minus y1 over x2 minus x1. Okay, a nice little chart for us to read and look at here. Compute and compare the average rates of change for patient temperatures. This is kind of neat. If you go into the medical field, you could work on a problem like this one day. And so you see after a certain number of hours, they took their temperature every hour, which is why you always have those nurses coming in and taking temperatures, because they analyze it. So from 0 to 1, well, from 0 to 1, I'm just doing average rate of change. You're just finding the slope. So 102 to 101, that's my change in y, over change in x. And so it was 1 degree Fahrenheit. That was the average rate of change. And you could say something like per hour, right? Because it's a rate. That's the change was 1 degree Fahrenheit per hour. How about from 3 to 5? Well, my change in y over change in x. And so that would be 1.5 degrees Fahrenheit. So from those hours, from hours 3 to 5, the temperature went up a little bit faster. How about from 1 to 3? Okay, you guys get the idea here. 100 minus 102, 3 minus 1. And so I get -1. So that was a good section. Maybe they gave him some medicine or something that helped bring the temperature down. So over from hours 1 to 3, the temperature went down by 1 degree per hour. And then again from 5 to 12, so you could do this whole segment here, right? 99 to 103 over 12 to 5. And so you get like some decimal, what is this? -4. So that's about what, -0.5 something. Okay, so it was definitely going down at a pretty steady rate for that last part. Okay, so again, average rate of change, slope. I'm going to pause this video and go on to our next video.